now that we have go back. Practiced with our properties and we know a little bit about proofs, let's get started with doing some algebraic proofs. So solving for x, these are the things that we've been doing for a long time. So let's just put them into proof form. So you are given, this is how they're all going to be set up. You're going to be given something and you're going to be asked to prove something. Okay, so you're given 4x minus 1 equals 27. And you're asked to prove how, if the given is true, then is x equal to 7. So we all know how to solve for x if we were just given 4x minus 1 equals 27. And we would do the math and we would get x equals 7. So this is not only asking us to do the math to get there and figure out what steps go in between, but then also why are we able to do that? So our proofs, 2-column is statements and reasons, just like the last video showed you. So we're going to put the statements, or remember this is like our Uno cards on the left. And then we're going to put the reasons, like we match the same color. They match the same number on our reasons, okay? So you always start with the given statement. Sometimes there's going to be more than one given statement. And so you're just going to put 1 on number 1 and then 2 on number 2. And then once you're done with all the given statements, then you can start going from there. But number 1 is always going to be the given statement. And your reason is simply that it's given. Okay, there's no other reason except for given. So what would be our first step in solving for x? Well, we got to try to get x by itself on one side. So we see that it's being multiplied by 4 and then subtracted by 1. So remember, we do the opposite. So we are going to add 1 to both sides. And when we do that, we're left with 4x equals 28. So what did we say we did? We add it to both sides. So go back to your properties list. That is our addition property. Simple enough, right? And then continuing on to solve for x, we would need to divide both sides by 4 to get x equals 7. What did we say we did? We divided, that's our division property. Okay, when we're doing algebraic proofs, we are just going through the steps to solve for x or whatever it's asking us to prove, and then saying what we're doing on each step, okay? So looking at the second one, 6x plus 7 equals 8x minus 17. That's what we're given. And we're asked to prove, how does x equal 12? So remember, number 1 is always our given statement, okay? So given, here's our equation. What would be the first thing to do to solve for x? Well, we would want to get all of our x's on one side, right? So we're going to subtract 6x from both sides. What did we say we did? We subtracted. So that's our subtraction property. And we were left with 7 equals 2x minus 17. Continuing to get x by itself, we would add 17 to both sides. Step 3 would leave us then, when we added both sides, 24 equals 2x. And what did we do to get there? We added, so that's our addition property. Now what do we need to do to get x by itself? We need to divide out that 2 from both sides. What did I just say we did? We divided, so that's going to be our division property, and that's going to give us 12 equals x. So yes, on our proofs, we aren't going to leave it at step 4, where it says 12 equals x, because what did it ask us to prove? X equals 12. So we want that last step to be whatever we're trying to prove, which is x equals 12. So when I just switch them on each side, what did we say that was? That's our symmetric property. Flip back to those properties. So a lot of times on these proofs, especially these algebraic ones, you're going to get a number equals x. But we're asked to prove x equals a number. You got to switch them, and that last step is going to be symmetric property. This final step has to be whatever you are trying to prove. Okay? Something to note. What did I say? I said that the first couple of things were going to be our given. Whatever is given to us. And it could be more than one. This step, this final step is never going to be, the reason's never going to be given. This x equals 12, that's not given to us. Even though it seems like it, because that's what we're asked to prove. That's not given, okay? Let's put this first one into our flow chart. I did say that we're mostly going to be using our two columns, but I want to look at this flow chart and see what we can come up with. So remember, in the boxes goes the, I do not mean to use that. In the boxes is the statements up here on the left, and then underneath we'll put the reasons. So our statement number 1 up here is 4x minus 1 equals 27, and that was given to us. Second statement, 4x equals 28, and that was our addition property. I'm literally just taking my 2-column proof and putting it into the flow chart way. Finally, x equals 7, and that was our division property. Finally, I wanted to show you a paragraph proof. So it's just putting all of that information from that first proof into words, into complete sentences, instead of in a table format. We are going to practice doing some algebraic proofs before we move on to our geometric proofs. These are going to be very similar to these examples using our properties. So let me know if you have questions.